All right, so here's the continuation on the section on parabolas. So we've talked about the case where the vertex is 0, 0. So now we're going to move away from the origin, and let's assume that the vertex is HK. Now remember, for a parabola, you don't have a center. You have just that vertex. So if the vertex is HK, we're going to have 4 different scenarios here. We're going to have the scenario where the parabola opens to the right, or to the left, or up or down. Now really the only difference in these, the right and left, is just the presence of a negative. For the up and down, same thing, the presence of a negative. Now you can tell which way it's going to open. If you look at these 2 equations, you'll see that they're exactly the same. So if the y is the one that's squared, it's going to open left or right. If the x is the one squared, it's going to open up or down. So depending on which variable is squared, that's going to tell you which way it opens. So if the y is squared, it's going to be right or left, depending on the presence or absence of this negative. Same thing with this. If the x is squared, then the presence or absence of that negative is going to tell you whether it opens up or down. All right, so let's just go ahead and dive right into our first example where the vertex is not the origin. So let's find the equation of the parabola that has a vertex at -3, 1, a focus at -1, 1, and then graph it. Let's just go ahead and sketch out what we've got. So we have a vertex back here at -3, 1. So there's my vertex, and my focus is at -1, 1. So there's my focus, there's my vertex. From those 2 points, I can tell which way it opens. Right? So we know that it's going to open toward that focus. So we know that it opens to the right. That tells me which form I'm going to have. All right? So the fact that it opens to the right tells me I'm going to have a y minus k squared equals 4p x minus h. Because it's to the right, that's going to be positive, and the y is going to be the squared variable. My vertex is my h and my k. So that vertex being -3, 1, I can tell that my h is going to be -3 and my k is going to be 1. The p-value I can also get from this. The p-value is the distance from the vertex to the focus. So that's at -3, that's at -1, so that's a distance of 2 units right there. So I get y minus 1 quantity squared equals 4 times 2, which is 8, and then x minus -3, which we know is the same thing as x plus 3. So here it is written a little bit nicer. So there's the equation. Just wanted you to see all that. Now in order to graph it, we're going to need those lattice points. Okay, the lattice points are going to tell us how wide the parabola is. So to find those lattice points, we're going to use this absolute value of 4p over 2 formula. So p being 2, we get 8 over 2, which is 4. So this tells me that I'm going to take from the focus, on either side of the focus, I'm going to go 4 units. In this case, because it's opening to the right, I'm going to go 4 units up and 4 units down. Okay? So that's going to be 4 units up and down. That's going to change the y value because we're going up and down from the focus. So those lattice points are going to be at -1, 5 and -1, -3. So you can get those by just counting, you know, based on the graph here. You can just say, okay, I got to go 4 units up. So from 1, that puts me up there at 5. 4 units down puts me down here at -3. Those lattice points are needed in order to tell you how open or how closed that parabola is. So those are something that is needed. The lattice points are always on either side of the focus. I call them lattice points because they are this line that connects them is called a lattice rectum line, and I just cannot bring myself to say that. So we're just going to call them lattice points, because I guess apparently I'm just a 8-year-old boy at heart. So anyway, that's what the graph would look like for this parabola. All right, let's look at another one then. Let's find the equation of the parabola. This time we're not going to graph it. And it's got a focus at -1, 3 and a directrix at y equals 5. Again, let's just graph what we have. So -1, 3, and that's a focus. And my directrix is the line y equals 5. So this line crosses the y-axis at 5. So I'm going to go up here to 5, and then there's my directrix up there. So y equals 5. This tells you a lot of good information. The vertex is halfway between the focus and the directrix. So if this is at 3 and that's at 5, all right, so that tells me halfway between must be right there at 4. So there's my vertex right there at -1, 4. My p-value is that distance from the focus to the vertex, or vertex to the directrix, whichever way you want to look at it. That's 1. And I can tell that the parabola is going to open downward because it opens from the vertex toward the focus. So that's everything that I need in order to get my equation. So the equation, because it opens downward, is going to have this form, and it's going to have a negative here. Remember, if it opens up, that's a positive, but because it opens down, that's a negative right there. And then just filling in the stuff that we know. The vertex being my h and k, so I plug in for h and k. My p-value was 1. Clean that up, boom, equation. So these are kind of nice. I like the ones where we have to find the equation because those are pretty short and sweet. So if you want to do this without the graph, you certainly can. I like to just get a visual of what's happening because I think it helps me. All right, example 6. Here we go again with the standard form. So we've got this x squared plus 4x minus 4y equals 0. Now fortunately, parabolas only have one squared variable to them, so we don't have to worry about completing the squared twice for parabolas, like we did with the ellipses and hyperbola. So I'm going to get those x terms together, and I'm going to move this y term to the other side of the equation, because we know that the standard form of a parabola has the x's and y's on separate sides of the equals. This already has a coefficient of 1. Awesome. So I just need to complete this square. Half of this is 2. 2 squared is 4. And then I need to balance this out over here. This factors into x plus 2 quantity squared. This one I'm going to factor out of 4. Because we know that that standard form over here has that coefficient of 1 for that y. So looking at that coefficient of y right there, that y minus k, we need a 1 right there. Okay, so looking at this, we can already see that h is going to be -2, that k is going to be -1, and this is 4p. So if 4p is equal to 4, that makes p equal to 1. Alright, so there's all the stuff of getting it in standard form, and I realize that this is a hot mess, and I am so sorry about that. That was just kind of me saying, hey, remember that we got to use those opposite signs because of the formula has a subtraction in there, and then my graph ran into it. It just broke bad, and I got irritated with it and was like, forget it, it'll be okay. From this standard form, we can tell the vertex, right, which was the hk, we could tell p was 1. The focus and the directrix. So let's just look at what we've got so far. We've got that vertex at -2, -1, and we know that it's going to open upward. Okay? We have a p-value of 1. Now what does that tell me? That tells me that 1 unit up, because it opens upward, right there is my focus. And then 1 unit down is my directrix. So I can already tell what my focus is going to be. My focus is going to be back here at -2, 0. So I have its coordinates. Last up are those lattice points. So we just need to be able to find those points on either side of the focus. Because this is opening upward, my lattice points are going to determine the width of this parabola. So we're going to use that whole absolute value of 4p over 2, p being 1, so that's going to be 2. So 2 units this way, so if that's right here at -2, so 2 units over here, boop, right at the origin, and then 2 units this way, boop, there's my other lattice point, and we just play a game of connect the dots. Remember, the focus is not one of the dots to be connected. So I was really determined to keep this on one page, and I did so at the expense of this kind of looking like a hot mess. These little thought clouds are just my way of reminding you that this y plus 1 here is the same as y minus -1. So that's where that -1 came from. And this is x minus -2. So just a friendly reminder of those signs. Okay. So next up is finding the standard form of the equation. We don't have to graph it, so this one's going to be pretty short and sweet. Because the y is the squared variable, I left the y's on one side and I moved everything else to the other side of the equation, okay? Once I got that done, I'm set up to complete the square. That's what this pink stuff is. So I took half of the middle term, half of 2 is 1, square it and get 1. I could go ahead and complete that square because this is an understood one right here. So because I added 1, I'm going to add 1 over here to keep it balanced. This factors into y plus 1 quantity squared. I'm going to combine those like terms. And then just like I did with the last example, I'm going to factor out, in this case, it's going to be a -12. That way I get that x, that coefficient of x right there to be 1. Alright, so that's about it. We don't have to worry about finding the vertex, focus, none of that stuff. Alright, I just asked you for the standard form, boom, done. So a satellite dish is shaped like a paraboloid of revolution. Now what that means is that a parabola that has been revolved around an axis of some sorts is going to form kind of a three-dimensional parabola, or like a satellite dish shape. Okay, it's called a paraboloid of revolution. The signals that emanate from a satellite strike the surface of the dish and are reflected to a single point where the receiver is located. If the dish is 8 feet across at its opening and 3 feet deep at the center, where should the receiver, oh God, be placed? Now the receivers can be placed at the focus. All right, that's how these satellite dishes work. That parabolic form in there that you have. So if you have this kind of parabolic shape and you've got that receiver in here, what happens is the any of the signals that are coming in, no matter where they hit in that parabolic shape, they are reflected toward that focus. That's the whole thing about this shape. No matter where they hit, boop, they are all reflected to that same point. So this is the opposite of how a flashlight works, where a flashlight has the bulb here at the focus and all these mirrors out here are taking this bulb that's emanating light and reflecting it outward. So this is kind of the opposite of how that's happening. So here's what we need to do. We need to set up some kind of an equation for a parabola and then find the focus. So we know that it's 8 feet across, so this one should be reminiscent of the truck problem we did back in the ellipse section, you know, where it was like 50 feet across. So this one's 8 feet across and it's 3 feet deep. I situated it so that the vertex was on the origin because we know that those equations are nicer to work with. I could have positioned it anywhere, so why not put it on the vertex on the origin, you know? In doing so, that puts these points out here. Those, do not assume those are lattice points. They're not. They're just points on the parabola. If you assume those are lattice points, then that would be assuming this is the focus right here, and it's not. These are just 2 points that just happen to be on this parabola. All right, so the equation, I've got a parabola. It opens upward. My vertex is 0, 0. That means my h and my k are 0, 0. My p-value, can you tell what the p-value is going to be? You might be like, oh, it's going to be 3. Well, we don't know what p is going to be because it's the distance from the vertex to the focus. If we knew what p was, we'd be done. So here's what we got to do. We got to find the value for p. So I'm just going to plug in something for x and y. That's where these points come in. I can plug in either one of these points and I'll get the same value of p. Now the reason for that is you can see if I plugged in x, y, 4, 3. If I had used -4 here, -4 squared would be the exact same thing. So I get 16 equals 12p, so p is equal to 4/3. All right, so that's 1 1/3. That means from here, if I go up 1 1/3 feet, that's where my focus is going to be. So the focus should be 4/3 or 1 1/3 feet above the vertex. So that's where the receiver should be placed. All right. Okay, so a lot of these are going to use, well, all of them are going to use these formulas on this sheet. So just practice using these formulas as you're doing the homework. All right, so just make sure that you're writing these formulas down so that you know which ones you're using as you go along here. So that concludes section 12.3.